Good day, everyone. Thank you for taking the time to watch our presentation. We are from Group 413, and today we are pleased to present our project titled DooRama, Design and Development of an IoT-Based Door Security System with Knock Detection using a Sound Sensor and Artificial Intelligence Pattern Recognition, also known as DooRama. In this presentation, we will explain the background of our project, its objective, the system design, implementation, and the results we achieved. Next. Uh, Here we have our objectives and problem statements. I'd like everyone to imagine this situation. You're rushing home after class and you're tired, carrying your bag, and when you arrive at your front door, you can't find your key. For our project, we have an objective to solve that problem. We want to develop an IoT-based door security system which will allow people with different methods to get into their homes. Next. Will be explained by Putri Balkis.
This is a slide shows the main features and benefits of our system. First, our uses no pattern authentication with sound sensor. Then it verifies the user voice using a resemblizer and consign similarity. The system also provides automatic door locking using a servo motor and supports real-time monitoring of door status and access logs. Finally, it applies multi-layer authentication by combining knock pattern and voice recognition. The main benefits enhance security without physical keys, low cost and scalable prototype, real-time monitoring and access tracking, and easy to use and customizable. Next. This is for chart system. First, the system starts and initializes all the hardware components. Then the door is set to locks. After that, the system enters standby mode and waits for a knock. If no knock is detected, the system keeps waiting. If a knock is detected, it continues the next process. The system extracts the features of the knock pattern. Next, the AI checks whether the knock is valid. If it's valid, the knock pattern is compared with the stored data in VS. If doesn't match, the system returns to standby mode. If the knock match, the user give a comment as the second authentication. The system extracts the features. The AI, the voice, and compares it with the stored voice data if the verification files access is denied. If both authentication and success, the server unlock the door. The user can now open the door. The system waits until the door is closed. After the door closed, the server lock it automatic. Finally, the system returns to standby mode and waits for knock the user. The next slide will be explained by Rahai.
Okay, the first, the EMP441 microphone, phaser, and vibration sensor and magnetic switch collect the input data. Next, the ESP32 receives and process the data from all sensor. Next, the battery supplies forward to the mini UPS 5V. The mini UPS 5V provides a stable power supply to the ESP32. If the authentication is successfully, the ESP32 activates the servo to unlock the door. The LED and buzzer provide visual and audio feedback about the authentication status. Last, the hardware prototype performs the door locking and unlocking process based on the authentication result. Next. Next, design and equipment scheme, system architecture. First, the battery provides power to the system. The TP4056 charges and protects the battery. The boost converter provides a stable voltage. The ESP32 controls the entire system. The input device collects data from the microphone, page sensor, and read switch. The system verifies the user voice and knock pattern. If the authentication is successfully, the server unlocks the door, while the buzzer and RGB LED provide status feedback, and authentication records are stored in the database. The speaker verification server processes the voice verification. The web dashboard display the activity logs and status system for IoT. The next slide will be presented by Team Alia.
Sorry. Okay.
Sorry, Shiva.
Okay. First of all, the user will knock on the doors. Then, the vibration will get captured by the piezo sensor, which will send to the SP to identify if the knocks pattern are valid or not. And if valid, the user have to input their voice and it will captured by the sound sensor, and the sound sensor will send to the ESP32 and will be sent to the server with broker, through broker. And if the both of the input were valid, then the light and the buzzer will active, and the server will unlock the door. Okay, so here's the implementation and the result. For number one, we have the IoT hardware system, where we put all the component in the acrylic and we manage all the cable system, so it will go as we plan it. And for the second picture, we have the mosquito broker for the communication through IoT and our database. And here, our login page on our website and our dashboard. And we have the status page and the setting page for the IoT. Okay, the next one will be explained by Alia.
Explain of the lesson learned. First, we learned the importance of integrating the IoT and AI to create a smarter and more secure their security system by combining this technology, and the system cannot only do monitoring the activity but also authorize the knocking patterns and the voice verification. Second, we gain practical experience in social validation and pattern recognition. We learned how to collect data, adjust sensitivity, and train the 10 model. Third, this project strengthened our problem solving and troubleshooting skills throughout the development process. We faced several technical challenges and learned how to solve them. Fourth, we improved our teamwork and communication skill by working together, sharing responsibility, and supporting each other to complete the project successfully. But finally, we realized that the testing are essential to ensure that every company function properly. Next. Okay, this is our documentation with our manager project. Next. Okay, that's all our presentation from Team PBL 1413. Thank you for your attention. Wassalamualaikum warahmatullahi wabarakatuh.